Structural engineer Fred Severett is based in New York City.
The quality of the connections depends to a very large extent on the quality of the bolts. If the bolts are not capable of taking the full tension for whatever reason, then you're in big trouble with the connection. And so it's very important to get the right kind of bolt and make sure that it's tensioned properly.
Mr. Severett refers to the critical importance of using quality bolts properly tensioned. The question is, can proper tension be achieved using torque measurement? Torque is rated in foot-pounds. A foot-pound is 1 pound of force exerted at a radius of 1 foot. In erecting steel structures, there are several methods of measuring torque. Here are 4 common ones. Installation can be done by using a torque control impact wrench or by a twist-off bolt. Inspection is usually done with a dial gauge torque wrench or a breakback torque wrench, as used in certain parts of the world. On a simple torque wrench with a dial gauge, the operator watches the indicator needle move to a prescribed number of foot-pounds as the wrench is used to turn the nut on the bolt. When the operator reaches the number, he stops turning the nut. To demonstrate the variable nature of the torque-tension relationship, we will use this lot of conventional 3/4-inch A325 high-strength bolts, nuts, and hardened washers. The lot is correctly manufactured. What differs is the condition of the bolts: lubed, dry, and rusty. The amount of clamp load or tension provided by the bolts will be measured by a Skidmore-Wilhelm bolt tension calibrator. Bolt tension or clamping force is measured in pounds or in kips, meaning thousands of pounds. A calibrated torque wrench is used to measure the torque or twisting force used in attempting to tighten each bolt. The question is, can proper clamp load be achieved using torque as a guide? We start with a well-lubricated bolt. The bolt is inserted into the bolt tension calibrator. Bolts of this particular size and type are designed to produce a clamping force of at least 28,000 pounds or 28 kips. A dial gauge torque wrench is used to turn the nut and tighten the bolt. The bolt is tightened to just over its minimum required tension of 28 kips, tightened to 29,000 pounds, requiring 220 foot-pounds of torque to achieve that tension. Therefore, the assumption is that 220 foot-pounds is the proper value to use as the torque to achieve or confirm at least 28,000 pounds of tension in each bolt. In actual practice, the average of 5 bolts is used to determine the torque. Here is a second bolt from the same lot. The only difference is that this bolt is somewhat dried out and has less lubricant on it. Mechanically and physically, it is otherwise similar to the first bolt. The bolt is inserted into the calibrator. The tension dial is covered because in an actual connection on a job site, the installer's only guide is the torque indicator on the torque wrench. The installer applies 220 foot-pounds of torque, the same as before, and the resulting clamp load should be the same, at least 28 kips. Let's take a look. We see there is only 12 kips of tension in the fastener, not the required 28. Even though the same amount of torque was applied, the clamping force is way off the mark. The situation is made even worse where bolts are allowed to rust, a condition all too common on many job sites. Here is a third bolt, a rusty one from the same lot. Again, 220 foot-pounds of torque is applied in attempting to tighten the bolt. Let's take a look. This time, only 6 kips of tension, where 28 is required. The effect of rust has again made reliance on torque measurement useless. To review, the lubed bolt developed a clamp load of 29 kips, the dry bolt a tension of 12 kips, and the rusty bolt 6 kips. Although the applied torque was always the same 220 foot-pounds, 90 torque control bolts are also demonstrated. As before with the conventional bolts, these twist-off bolts have also been grouped by condition as lubed, dry, and rusty, representing the various conditions hardware is found on a job site. The question is, how much tension will these big twist-off bolts provide when their ends shear off automatically? 1-inch A490s are intended to provide a minimum clamp load of 64 kips each. Let's try the rusty ones first, since experience has shown they'll probably be the worst. Here's the second rusty bolt. Here's a third rusty bolt. Will the clean, dry TC bolts do better? Here's a second dry bolt. And a third dry one. Finally, the lubed bolts in their original as-received condition. Remember, we're still looking for at least 64 kips minimum tension. Here's the second lubed bolt. At last, we're up to tension. And the final lubed bolt. Wide scatter in this sampling, from 71 to 24 kips. Although some of the scatter is presumed to be caused by variation in the break-off torque of the spline end, the bigger problem here is as lubrication is reduced, the torque cannot be increased to compensate for the increased friction in the threads. The spline breaks off when it reaches a set range of torque values, whether the bolt is tight or not. Torque should, in our opinion, be avoided at all costs, particularly when using fasteners outside the factory environment. Let us again remind ourselves why proper clamping force is essential in all slip-critical connections.
One of the important things in a braced frame of this type is the connections between the steel members. If you look at this sample connection here, you have forces coming into that connection that can be between 12 or 1,300 kips to almost 2,000 kips. Now these loads have to be transferred from one steel member to the other, and basically it's done with bolts in this particular building. One of the problems that can occur in a bolted building such as this is that we design the connections assuming that there'll be no slip at the bolts, and it's known as, in a wind system like this, normally we'll use a slip-critical connection.
Under no circumstance should torque measurement be relied upon to consistently produce uniform clamp loads that every bolt must achieve.
Properly tensioning bolts is not a compromise on slip-critical joints described by Mr. Severud. To steer clear of loose bolts and to ensure structural rigidity, specify Turna Sure's direct tension indicators in project specifications.